everyone. I'm Julia Owen Ramos. I'm a PhD candidate at the University of California, Davis in the graduate group in ecology. My research focuses on using DNA to study wildlife populations for conservation and management. Today, I'll tell you a bit about my research that focuses on the evolutionary history of island spotted skunks. Island spotted skunks are small carnivores that live on two of the Northern California Channel Islands, Santa Rosa Island and Santa Cruz Island. They're a subspecies of the mainland western spotted skunk, and in terms of morphology, island and mainland spotted skunks are so similar that mammalogists once considered the island spotted skunk to be a weak subspecies and thought that they may have been transported to the islands sometime since European colonization. However, genetic studies have begun to build a case that the island spotted skunks have been on the islands for longer than traditionally thought, so we wanted to use genomic information to further investigate. We performed whole genome sequencing on 2 samples from each island and 2 samples from the mainland, and we focused on using measures of inbreeding and estimates of historical demography to describe their evolutionary history. We measured inbreeding using runs of homozygosity, which are segments of the genome where the pair of chromosomes are identical by descent. Inbreeding creates very long runs of homozygosity that are broken up into smaller and smaller segments over generations due to a process called recombination. When we looked at the size distribution of runs of homozygosity in each genome, we saw that island genomes lacked long runs of homozygosity. This pattern is consistent with the islands having a bottleneck or founding event far enough in the past that long runs of homozygosity have had time to break up into smaller segments. To begin investigating divergence times, we used a method called pairwise sequentially Markovian coalescent, or PSMC. This method estimates the change in effective population size over time. We found that the islands and mainland population sizes began to diverge around 20,000 years ago. However, with this method, we didn't have the resolution to determine when island populations separated from one another. So we used a related method called F1 hybrid PSMC. We artificially created an F1 hybrid using a genome from each island. Then we use that hybrid to run the PSMC program. When PSMC is used this way, the time of divergence is signaled by an exponential increase in population size. With our hybrid genome, we saw that the 2 island populations must have also diverged around 20,000 years ago. So all of this evidence points to island spotted skunks arriving on the islands from the mainland roughly 20,000 years ago and separating into the 2 distinct island populations shortly after. Thank you for watching my video, and thank you so much to the ARCS Foundation for helping me fund this exciting research. I hope to see many of you at the symposium in April.